Welcome guys, in this video we are going to study one-sided confidence intervals. The confidence intervals that we have studied so far are known as two-sided confidence intervals since they had both lower and upper bound. Well, in some cases we are only interested in one bound of our confidence interval. For instance, let's take a look at the following example. A standard treatment exists for a certain type of cancer, and the patients receiving the treatment have 5-year survival rate of 30%. A new treatment is proposed that has some unknown survival rate P. We would only be interested in using the new treatment if it were better than the standard treatment. So we are only interested in whether this new survival rate is greater than 30% or not. So we'd like to build confidence interval with only lower bound. And suppose that 40 out of 100 patients who receive the new treatment survive for 5 years. Can we say the new treatment is better than standard treatment? So basically we have some population. We draw a sample, so this is for new treatment with unknown survival rate P. Then we draw a sample of 100 patients, n is equal to 100. These are x's. And then we find that P hat, which is equal to the sum of x's over n, is equal to 0.4. Now, if n is large enough, in our case n is large enough, then we can say that P hat follows normal distribution with mean of P and variance of PQ over n. Now we'll be interested in finding probability that this unknown parameter P is greater than some P, let's call it P threshold, which is equal to, so we are interested in some minimal value of P such that this probability is equal to 1 minus alpha. So that will be 100 multiplied by 1 minus alpha percent one-sided confidence interval. Okay, then by definition of a normal distribution, probability that P hat is less than, let's say, Z. Let's standardize first. P minus P over root of P hat. So we are switching PQ with P hat, and Q hat is less or equal than some critical value Z1 minus alpha. This time not over 2 is equal to 1 minus alpha. Okay, so we are interested only in values for our standard normal that are left of some critical value Z1 minus alpha over 2. Okay, now you might be asking a question why we are using here, we are setting the value of our standard normal being less than some value when in fact we need P to be greater than something. Since here, if we will express P in terms of other variables, then let's see what's going to happen here. Then P multiplying both sides by root of P hat Q hat over n will get, and moving this term to the left and P to the right, then we'll get exactly what we need. We'll get P being greater or equal than P hat plus P hat in fact minus, right? Yes. P hat minus a root of P hat Q hat over n multiplied by Z1 minus alpha. So that will be equal to 1 minus alpha. All right, so upper one-sided confidence interval for binomial proportions is then defined as P greater than point estimate minus critical value multiplied by standard error. And in fact, you can use a similar technique to build one-sided confidence intervals for all other cases. So you will have your point estimate minus critical value multiplied by standard error. In all other cases, all you have to be careful about is this critical value. In case when we're building two-sided confidence intervals, you would use Z1 minus alpha over 2. This time you would use for upper one-sided confidence interval minus Z1 minus alpha. Okay, so let's finish up our example. So 40 out of 100 patients received new treatment, survive for 5 years. So point estimate in our sample is 0.4. Then building 95% upper one-sided confidence intervals, we choose a critical value of 1.64 and substituting the values for p hat, q hat here, we would get the following one-sided confidence interval. So p is greater than 0.319. And in this case, since p is only defined from 0 to 1, you will have a right endpoint, which will be 1, but this is not true for all cases. If you will have some other continuous random variables that is unbounded, then you would have only or your left bound. So this is 95% upper confidence interval for binomial proportions. Now, to build a lower one-sided confidence intervals, we can use a similar technique. This is our standard normal random variable. To find probability that p is less than some thresholds, we need to set our standard normal random variable being greater than some critical value. So we pick some critical value. Let's write this down as minus this value -1 minus alpha. I should have alpha here, not alpha over 2. And we'd set our standard normal random variable being greater than this value, than this critical value. Then following similar steps, we'd end up with the following formula for a lower confidence interval. So point estimate plus critical value multiplied by standard error. Well, that concludes our short lecture on one-sided confidence intervals. Thank you for watching.